right, so for week 5, we are going to start talking about chemical reactions and chemical equations. So we are in chapter 6 of our text. This is the other text that we used a couple of years ago, and I still have some slides from that. So we're going to talk through. First, we're going to have an introduction to chemical reactions. And in videos later, we will talk about chemical equations and balancing of chemical equations and the different types of chemical reactions that we will typically see. Okay, so to start out with, we're gonna talk about just chemical reactions in general. All right, so recall from the very first week of class that we talked about chemical changes as opposed to physical changes. Physical changes is when something changes state from a solid to a liquid to a gas. A chemical change is when you have a substance that's converted into some new substance. Okay, so we create something new. So that is what defines what a chemical change is. And typically we can recognize that a chemical reaction has occurred by a variety of different means. And we'll illustrate them here, and I'll show you some pictures in a moment. All right, so we can recognize it by there's a change of color. We'll often see a change of color in our, when we see a chemical reaction. There's also formation of solids, and you've seen that before when the formation of a precipitate, and possibly the formation of bubbles. That's another very common way. So if you think when you react vinegar with baking soda, many people have seen that reaction. That's a chemical reaction, and it gives off a gas which comes out as bubbles. So we're going to see a chemical change, and we want to know, what are some of the general ways that we have evidence that we've had a chemical change? So one of the things that we can say is that there's going to be possibly a change in color and texture, right? So if you take iron, these nails, and you leave them out in the rain, you're going to get rust on the surface of those on the surface of those nails. And that rust is a chemical reaction between the oxygen in the air and the iron itself. So that we have a chemical reaction that has changed the color and the texture, because rust is kind of flaky, iron is solid, of course. And also something happens on copper when you get this green patina on copper. That's the same idea. The oxygen in the air is reacting with the copper, and it forms a new compound, copper oxide, on the surface. So we see that. Okay, so that's our evidence for a chemical reaction. And we've got multiple other ways that we can see with our eyes a macroscopic evidence that we have a chemical change. So like I said, if you have gas produced, so vinegar and baking soda, but also if you were to take a 9-volt battery, and I do this as a demo in the class, if you take a 9-volt battery and you put it in the water, the voltage of the battery is enough that it will convert the water into its components. So water is made of H2O. You can separate the hydrogen and the oxygen just by putting a battery in water. And you can see that the bubbles that are occurring, those are two different kinds of gases coming off the different plus and minus, positive and negative sides of the battery. So one will have hydrogen gas coming off, and one will have oxygen gas coming off. So gas can be produced. That's a common thing to see. A second thing that we'll see is the formation of precipitates. So we saw this in when we mixed the seawater with silver nitrate, that we formed a cloudy white precipitate and in our solution. So here's an example of a different kind of chemical reaction. We take this one component, which is liquid, we mix it with another liquid, and what we create is a yellow, cloudy solution. If this was stirred up, you'd see it was cloudy solution, but if you let it sit, that precipitate that forms will settle down to the bottom. So those are solid particles that we've created a new compound, some new compound. And I wanted to point that out here too. You're creating a new compound. You're taking water, and from the water itself, you're creating two kinds of gases, hydrogen gas and oxygen gas. So New compound, totally new and different properties. Okay, and then the other thing we'll see is that we'll often see some type of color change. So later in the class, when we do what's called a titration, we will see color changes, and that will indicate when we have a chemical reaction that has occurred. All right. So, and then finally, a very common evidence that we have that a chemical reaction has occurred is that heat can be a large indicator that you've had a chemical reaction. And this can happen in two different ways. So we can say that heat is released, and we talked about this in chapter 1, when heat is given off, so think exo meaning exit, given off, going out. When that's given off, you have an exothermic reaction, and you can see that this is what's happening in a Bunsen burner flame. So a chemical reaction is happening between the methane that's in the that's coming through the Bunsen burner and the oxygen in the air, and it's hot enough that it sustains this flame that you see. Chemical reaction right there. Second type of heat that you can see is the other way around. So heat can be absorbed into into the system, and what occurs when that, or what happens when that occurs, is the thing gets colder. Right. So these ice packs that you see, they start out, it's just regular at room temperature, and then you break something on the inside of that ice pack, it mixes the two compounds together, and immediately the thing starts cooling down. That is an indication that there's a chemical reaction occurring within that bag, and it is an endothermic reaction. So heat is getting absorbed into the reaction, and that's cooling you off, for example, if you have an injury, something like that. So we've got a variety of ways of where we see some kind of macroscopic indication that we have a chemical reaction. So next, we're going to talk about how we can start specifying how we mix things together and the types of things that those things will produce. And we'll do this through writing a chemical equation. So that's our next topic.